Hey, welcome to episode 18. Today we are going to be moving forward with trading signals. And to recap, we took like several sessions to create the project called Open Storage. After we already finished the first iteration of trading signals. What that means is that we had working one trading bot sending signals and another bot receiving the signals via a peer-to-peer network node that was working 100%. So we wanted to create the second iteration, which is an improvement over that, in which instead of sending the signals individually over the network node, that it wouldn't scale that well because each signal might contain a lot of information. Remember, you can put context information at each individual signal. So because that was not going to scale that well, and also because we realized that at the receiving end, you need all the signals of a certain candle. You cannot start processing a candle without having all the signals already there. Otherwise, it wouldn't be synchronized enough. So that lead us to conclude that sending individual signal is not a good idea. We have to package them into candles, a candle worth of signals. And instead of sending all that information over the network, we would have bandwidth multiplied by all the nodes of the network. And every time we have to cycle through thousands or potentially hundreds of thousands of subscribers to these signals, we will be sending individually each time all this information. So the best solution was to, instead of send this information, we store the information at some place on the internet where anybody can access them, and we encrypt it, cryptographically encrypt it, and we save it. We create a hash for the name, and we create what we call a file key. So the file key is the password to decrypt information and essentially where the information is going to be located. And what we transmit over the peer-to-peer network is just the key, which is really a brilliant idea because this reduces the bandwidth to the minimum and it keeps the same properties that we want to achieve of being um, of whoever has more token will get the signal first because the network is organized by the amount of token power of the nodes, and then it's distributed by the amount of token power of the entities connected to these nodes. And at the same time, we are adding the properties of self-ownership of information because each user emitting the signals will save at the open internet the information at a place they control themselves. So whether it is a GitHub repository, that is one of the options, or a server in the cloud, which is going to be another option, or any other storage provider in general, the user producing that information has 100% of control, and whenever they want to delete it, they can delete it and it's gone. Also, it will be quite resistant to censorship for instance, from the point of view of the storage of the storage provider. For instance, GitHub provides free repositories to their user base. So if you use one of these GitHub repository as the storage for the signals you emit, then you are good. And also on top of that, all the information at the repository is encrypted. I'm going to show you what we did with the open storage. If you take a look at my repository here, at my account, I have my trading signals. That is the repository that I configure here at my user profile. We added this user storage, GitHub storage. That is it is the first storage provider. And here we have a storage container. Okay. So I might have as a storage container any repository on GitHub on any user account. It can be mine, main user account, can be secondary account, or whatever I want. And the repository name, and that by linking my social trading bot, configuring the available storage where it can store information on the open internet. As you can see, I have a storage container reference to the one that I defined there. And just with this small configuration, and it obviously a task running a trading bot pointing towards this social trading bot, then the results are that the signals are going to store in this way, like in a folder structure based on a timestamp, okay? And each file will have a name that is a hash of the content, okay? So only the one knowing the hash will be able to know which is the latest file added here. But even if you can guess it, or you can list all the files in this folder, then the information is encrypted, okay? So you need the password to decrypt the information. The password is going to travel through the peer-to-peer network that is organized based on the token power of the actors involved, okay? So that's how all the circuit is set up, and I believe it's quite powerful. So now, sorry, what we are going to do today in this episode is to start the second iteration of trading signal. We are going to disassemble a little bit what we have working, and we are going to connect it to this circuit, okay? So let's go to the code. Okay, so this is the network code. I don't need this now. We will the open storage. So as a reminder, we add this here, set up open storage at the task initialization code. So if there are in existence these nodes, then we will set up the storage, and we had some test here still there. The important thing is that we are going to connect to this module open storage client that it is stored here. So we have access to this, and it's one module per whole task, okay? The open storage client. This is the guy that receives information to be stored, and every 1 second it's saved into a file after encrypting it. Good. So yeah. So on the other side, we had our the Visual Studio Code where we were working with the signals, the trading signals. And what we had is this module, Outgoing Trading Signals, that is creating the signal message. And it was sending this message to this guy, peer-to-peer network start, okay? And even inside there, we made an upgrade to this, to the message handling here, so that we can handle the situation where many messages are coming and they cannot be delivered, so they are queuing here, and when we have the channel open to the peer-to-peer network, it will deliver all the messages, so messages are not lost, which is going to be very useful because now these messages are trading signals, individual trading signals, but later they are going to be the file keys. Okay, we will replace this by the file keys. Good. So what is missing here in the middle between this guy and this guy is a module that it doesn't exist now. That is the one who is going to accumulate all the signals and package them into a bigger message or a bigger record with all the signals of a certain candle. Okay, because we realize that it's not useful to send individual signals. Signals are very detailed information of some action done. So we are going to let them accumulate and package them into one candle, and then from there we will send it to the open storage to be recorded. We will get a key of the file once it is recorded, and the workflow continues. With that key, we will send it through here, through the peer-to-peer network start. Okay? So this is the game plan that we are going to follow today. So get ready because there will be some coding. Okay, so let's go on and create this missing module. First, where is the module going to be? Where does it belongs? Probably it belongs in to the same project, Trading Signals. So that's why I open this here. So I get to the folder structure. Okay. And I'm going to add one more file here. And what is this module going to do? It's going to pack signals per candle. Pack a candle worth of signals. Maybe I can continue with the naming of outgoing, but instead of trading signals, trading signal candles or outgoing candle signals. I want to pick the right name so that then we can remember this and make a mental map. So yeah, this is not going to be used for incoming signals because the incoming circuit, how it would work today, let me check that out. The incoming signals is here. Okay, it's getting, yeah. The network interface is the place so far where signals are accumulated, which is not really, to be honest, it's not really the best place because the network interface is where information is coming through at the network, okay? So, but so far it is here. Yeah, this shouldn't know about signals, to be honest. When when this receive these signals, this should send it somewhere else that is part of the signals project, okay, the trading signals project. This is just the interface to the network. But what I'm going to do is that first I put all the pieces together and make it work. Then I'm going to do another round reorganizing the code a little bit so that it gets conceptually where it should be, okay? Because otherwise it's too difficult to do everything at once. Okay, so coming back to here, I'm going to create one file that is going to be, and probably the file that is missing at the incoming that replaces the code that is here is the one similar to the outgoing candle signals, okay? Incoming candle signals. Well, I don't know. We will see when we do that part. So for now, mm, what I'm thinking is if we call it candle signals, the module, what does it do? It waits for all the signal of a certain candle to be there, and when it have a candle worth of signal, then it sends the signal, then it sends the package um, to the it sends the package to the open storage, and it receives a file key and it send it to the network. Or maybe not. Maybe the open storage send that to the network. And that is the workflow. Why it should come back. The storage is only storing information in the open for the reason of not sending that information over the network. So probably is the storage itself the one sending the information. The file key to the network. Okay, just to know which is the right name for this. So this is going to be outgoing candle signals. Okay, so we'll put it next to this guy, to the other outgoing trading signals, get into outgoing candle signals. Okay, so we will need first of all to go to the profile project schema look for this. Look for this and add here a new module that is going to be called Outgoing Candle Signals. Candle signals, candle signals, candle signals. So then this guy will have more or less the same structure here, but this is going to be called like this. So we will not need this and need this either. Okay. So here we start disassemble and rerouting the information. So when this signal is ready, what this guy is doing here, we are going to take it to the storage. No, this is not the storage. Network. Okay, this is the storage. Okay, we're going to replace this, what we imagine as a callback, and we are going to send this file key. Instead of a signal message, is a file key. So we will not need this guy, and we will not need this either. So now you can see how a successful file save triggers sending the file key over the network. Cool. And this guy, we are going to replace it to a call to outgoing candle signals. Um, but the question is, who is instantiating outgoing candle signals? It cannot be instantiated here because this guy is instantiated at different places all over the trading bot. So we need outgoing candle signals to be uniquely instantiated across the whole task, okay? So what I'm going to do then is I'm going to switch to this workspace and the task server here. There will be a setup to instantiate this guy only if there is signals involved, okay? How do we know if there are signals involved in a certain task? For example, if we can see this, or I would say at the bot level, if there is a social trading bot involved, the reason it is involved is because it's going to be either sending or consuming signals. Otherwise, user would not provide this node. Okay. So we already seen this here. So we have a bot and it has a bot social trading reference. And up to here is how we filter out when we have to set up that module related to signals. And by the way, I'm not 100% sure that this incoming and outgoing should be instantiated everywhere. Outgoing trading signals, this is instantiated at different places, even though, well, probably yes, because we are maintaining the state of the trading engine, and I wouldn't do that at the task level because we need the trading engine to be removed from memory at every execution. So we don't want to be at the task level because the task level is alive all the time. So I'm not going to question this right now. Okay, so let's move forward. I'm just going to copy this and adapt it a little bit, okay? So up here is good. From here on is not good. Here we will have an object which we're going to call outgoing candles signals, because we're also going to have the incoming ones. Okay, it was not here. It was candle in singular. It's not that it has to match, but in this case, better if it does. And okay, So I bet that we are going to have the same stuff for the incoming candle signals, because so far we were receiving the individual signals, but we will need to unpackage that candle worth of signals. So I'm going to go forward and create both. So we'll go a little bit faster. Incoming. And here, mm, so this outgoing candle we will get here, but this is going to go here. Okay. So we don't need any of this. And we can do this setup here. For the setup, we don't need this to be asynchronic. So now we will have this module instantiated here and available via this node path. And okay, so here are the modules. So in the outgoing case, we have this outgoing trading signal with a function called broadcast signal. And the incoming one, get all signals. Okay. Then here, the outgoing candle signals, we will add sorry, a function called maybe broadcast signal, the same. It's not actually going to broadcast it, but from the point of view that the one that is calling it, that's what it does. So broadcast signal I don't see that it's going to be an async function because it's just going to send it into the mechanism of the storage. Okay, what do I mean with that? It's going to do what we were doing here for testing. Although this is awaiting here, the open storage if you see what this persists that is just push something into an array that is going to be processed later. Okay, so this doesn't need to be an async function, and this guy doesn't need to await this, but it doesn't really matter because it doesn't even need to exist here. This is going to come kind of here at some point of here. So we are going to accumulate all the signals into a candle signals block of information and then send it there. Okay, so this outgoing is going to need this outgoing is going to need so I guess we're going to remove this test information, or we are going to comment it for now. So this guy is going to need okay, we already have this guy. Now the outgoing trading signals, it will need what we set up here. This guy, specifically this property, that is going to have this method broadcast signal, and here we will send the signal message. Okay, so this disappears. Now we are routing the message into here. So far, I don't see this being asynchronic because this is not asynchronic. This persists. So this shouldn't be asynchronic either. There's no asynchronic operations here. Okay, so broadcast signal, it receives the signal message. Okay, so now we have the routing of the outgoing more or less set up. So each outgoing signal is going to come through this module and is going to be sent to the open storage, but as a candle worth of signals. Okay, the next problem we will solve is how do we know when we have a candle worth of signals? Okay, how do we know that? One of the latest modification we did at the trading simulation level was to broadcast a signal there was a synchronization signal. I don't really remember the details, but there was a synchronization that is representing that the candle was processed, right? And this is what it's sending here. And here. Let me remember how how do we what what do we know about this synchronization signal? Um, where is this trading system coming from? Oh, okay, it's the trading system node. So this gets into here, outgoing trading signals. Node, a formula value undefined. So at the signal message, if we see the signal message, signal source trading system node type, if this type is trading system, that means that is the signal message signaling that a whole candle was executed, and that is exactly what we are looking for. So what we are going to do is to analyze this in here, and all the signals that are not the candle signal, we are going to retain them and accumulate them at an array. Sorry, hold on 1 second, please. Okay, so that's what we're going to do. So all the signals that are not the candle signal, we are going to accumulate them at an array, and then when we have the candle signal, we're going to send this accumulation of signals to the open storage, and then we continue accumulating again and again and again. When at the receiving end somebody opens that file, it will unpackage all the individual signals. It will put it wherever they are now, and the candle signal is there. Then it will eventually move its own simulation into that candle and consume all the signals that came before that candle. So that is how this is going to work. Okay, so outgoing candle signal. The signal message has signal source trading system node type. So if signal message signal is one of the properties of the object signal message, signal source trading system, signal message, signal source trading system, source trading system, node type, node type equals or let's say it's not equal to the node type trading system then we are going to do this. Thank you. So we are going to write this here so that it stays at the right place. We are going to accumulate all the signals that are not the signal, let's say the candle signal, which means the signal that represents that a whole candle has been processed. Once we receive the candle signal, then we send the whole package to the open storage. So here we will maintain an array. Um, I don't remember if we have an initialization of these nodes. We should have. Sorry. Each of these one nodes, we will do an initialize like this. Something is wrong here because they are both outgoing. Mm. We need this incoming to be here, and we need the property name here. More or less like this. So when we have the candle signal, we are also going to add it to the array. Okay, it seems that we already had a name for this. I'm a little bit worried about something here. It's the following. This is the code that it should be here, right? But as I'm sending this array. Okay. I'm sending this array. And to a guy that is going to save it somewhere until a second later happens to process this. And maybe it can process it, maybe not, or whatever. But then I resetting this. So in my mind, was not sure if the array is going to persist over there or it's going to be cleaned. But no, I think we are safe. This is just going to reset the reference to the array object at this variable. Okay. So it doesn't look like a very big deal. This is a small module. Let's check it out. When initialize, it creates this empty array, and it will be receiving signals one after the other until one signal is going to be equal to trading system. This we will put stop there. Signal source trading system node type. In this case, it will add a signal to the array, but it's going to persist the whole array at the open storage. Reset the array and continue processing. Okay, so it's going to be moving forward the package only when it receives a trading system type of signal. That's pretty much it. So this comes into the persist as a record is going to be processed later every 1 second. We already have this tested. So I believe that the mechanism is complete. The outgoing mechanism is complete. Let's recap. This was already working. Broadcast signals. It creates a signal object. It signs it. Beautiful. There's something here. The signing. The signing shouldn't be done for the signal information themselves. Probably what it needs to be signed is the key, the file keys. Because once I have a file key and I verify that the signature is from the entity that I'm following, then I just use that file key to go and retrieve the information. The file key tells me where the information is and the password to open it. And this is good because there are less things to sign. Remember that we discovered that signing was expensive. So we can sign first a much smaller message because the file key is smaller than anything than a single signal message. So I believe that yes, this signal is not, this is not the place. This is not going to have the signatures. But I don't want to disassemble this right now. I'm first going to go on the incoming signal workflow so that we can figure that out first. Okay. Then we will deal with the signing. Okay, so everything is incoming through the peer-to-peer network interface. I will make a small commit with this part. That is the outgoing emails workflow implemented. Okay. So what is going on here? The network interface is getting this signal received. The signal received okay. So we will start refactoring this stuff a little bit because otherwise it's going to get complicated. Okay, step by step. Signal received, it should be file key received. You're not receiving signals anymore. So let's check where do we have this stuff. I don't think these stuff are related to this. Yes. That, by the way, we are going to need to update this too inside the node. We cannot continue. Wait a minute. Or maybe we can continue calling them signals because specifically these are file keys. But they are, when they go through a certain circuit of the HTTP interface, they are actually signals. It's not the same signal that the trading bot is sending, but in the context of the peer-to-peer network, they are signals. The problem to having the same name is that it's going to be confusing. But I like the idea that the network knows about queries, events, and signals. Even if the signal, the individual signal, the trading signals Okay, so we will call trading signals, which is how we are calling them. Trading signals are the signals sent by the trading bot. Okay, a signal in general are the type of messages flowing around on the network, which in fact they are file keys. Okay, so probably here when we set signal receive, it's still a signal. Okay, so for now I'm not going to change this. It's still a signal. It's not a trading signal, it's a signal. These are outgoing trading signals, but these are signals from the network point of view. Okay, good. Problem solved without coding. Okay, there will be validations of signatures. Okay, so some of this code shouldn't be here, should be at the incoming candle signals, maybe, or somewhere else. Because what does this interface do? This interface represents the interface where everything coming from the network comes through. And that those are events or signals. So if it is a signal message, then I should forward this to the incoming candle signal stuff, which then is going to use the open storage to get the actual signal, the actual message with all the signals, unpack them, and put it in the same way that this was put in their stuff, right? So that's what we need to do. So this incoming stuff that is going to the network interface to get signals now is going to go here to get the signals. So we will have a function here, get signals, and in that function we are going to do a similar stuff that we were doing here, and this is going to be much cleaner. Okay, but at the same time we will need these incoming signals to have another method, which is going to be signals receive, which this guy is going to execute. Signals receive, and it's going to pass the signal in there. So It also needs this maintain function, which doesn't really belong here. Maintain this maintain is to maintain the information and not let it accumulate forever. So we have all this working here, but we are going to move it somewhere else. So first, the signal receive function, we are moving it in here. Signal receive. That means that all the validations that we are doing here, all the stuff is not going to exist. I just need to call this guy and tell him, hey, signals received. Okay? So the maintain function, it moves completely inside here. Completely. And the get signals, it moves completely into here. So we will have signal received, but we won't have these two guys. Okay, so this get very much simplified and it's more or less like an interface where things are coming through and they are forward to the right places. If it is a signal, then it goes to trading signals. There is a module from the trading signals project and not from the network. And pretty much that's it. So we will need these two maps. That, as I explained before, it's better to initialize the maps or whatever, the variables, inside the initialize function and leave this undefined here. Also, it's a good idea to finalize this in case there is an execution of the finalize function. Okay, now this is getting better and the overall structure is more solid. We have the same features, but in a module that belongs to the Trading Signals project, and that is accumulating the signals. The problem is that now over the network we are not receiving signals, individual trading signals, but a signal message that represents, okay, we're going to write this here. What we have just received are not trading signal, but a signal message represents the file key needed to locate and open the file or trading signal stored at the open internet. To get the trading signals, we will ask them to the open store. Okay. Well, so here it begins the procedure to recover with the signal message. The signal message it probably going to have, I don't know exactly the format of the signal message because let's check out what happened with the storage. When we have this peer-to-peer network start, we are send message file key. Okay, we're sending the file key. That is this object. But this is not the real signal message. This stuff need to be signed. So the message with the signatures is the signal message. But this is something that this guy needs to done peer-to-peer network start. So we have this guy here, peer-to-peer network start. Maybe we should change this send message because you are not going to send through the network start anything else but this kind of file keys. So I'm thinking about the naming of this, if send message is the right word. Because these guys still have to pack Pack this and sign it. Let me check something. Outgoing signals, outgoing trading signal. This signature, to sign this, we will need the private keys. And where is this coming from? Mhm. So there's a problem here that each individual signal might belong to different, in theory, they might belong to different social trading bots. As of today, you are able to reference any trading bot, any signal definition that in the end is defined by a social trading bot. So when we had that each individual signal was traveling, everything was good through the network because each signal is signed with the private key of the signing account of each social trading bot. So what happens if everything is packaged together into a file? Then it might happen that in that file we may have signals of different social trading bots. We might have signals of different social trading bots. So how do we solve that? We will have to create different files for different trading bots. If we want to maintain that flexibility, then the answer is yes. That would mean that we will need to do the handling a little bit more specifically. by social trading bot codename. Mm-hmm. Wow. So it was not that simple. Okay, let's see if we can do one first iteration without worrying about that. And then we come back and we see how to manage that dimension. Okay, so it was not that simple. Okay, incoming candle signals. We were here. We were also outgoing P2P Network start. When we are sending the message here, so at some point we will need to add the signatures. I'm wondering if this is the right place. Or maybe the outgoing guy. Maybe the outgoing guy. I add another function here. So when the storage finishes, it calls me back here. And a function that is broadcast the file key, broadcast file key. And here, because this is a module of trading signals, I can solve the problem and send it to the network start once I have everything signed and everything in place. I like this one more, so I'm going to do it like this. This is broadcast signal, and the next one is going to be broadcast file key. It's getting a little bit complicated. Okay, so function broadcast file key will receive a file key. So the other guy that was sending this will move this here, and we will use this. in here. Broadcast file key, and we will send the file key. And from there, this is not our problem anymore. The file key is now here. So then we are going to create the signal message, which is going to include the file key, of course, but also is going to include the signatures for that. Okay, so we are going to add the signatures here, and we are going to send the signal message over the network start, and the network start for it is just a message. Okay, so the circuit is good. I like it. But we still have the problem with the signals, with the signatures. Okay, because here we are signing on behalf of a certain application. What is the relationship with the application? The relationship comes from here. This is the application. So how do we know the user app code? We have this user app. Okay, so this, we can move it because this doesn't depend on the signal per se, like the social trading bot. The user app is something that is related to the peer-to-peer network identity that we are running upon. Okay. So this stuff, user app, maybe it's not per signal message, per trading signal message, but it's the broadcaster structure here would be part of the signal message itself. And by the way, this is not a signal message, this is a trading signal message. So let's start putting things as it should. Trading signal message. So the trading signal message is this, that includes a signal with a source, unique ID, timestamp, whatever. So the broadcaster information that today includes the social trading bot Okay, this part doesn't belong here. The social trading bot, yes. But if you're going to concentrate all the signals into one file per social trading bot, then this information doesn't need to be at every single object here. Also, we don't want to add too much information to the one that is traveling around the peer-to-peer network. So what are we going to do? Let's see. What if we move this outgoing to this object? Because also the network node needs to know the bot that is broadcasting this stuff. Okay? But not everything of this we will need, but let's see. So for sure, the user app is not going to be here. That means that probably okay, we are going to move the signatures from here into here. So this trading signal message is not going to be signed because the key, the signal message that is traveling is the one signed. If that is verified, then you just go and open the information that is encrypted with the password that they gave you. Okay? So this signing, we are going to move it here. And all these guys, we are going to move them here. So user app is this guy. It should have a configuration and it should have a parent node that it used to have all this, but it's going to have it here. Okay. Okay. So here probably we will not have a broadcaster at the signal message level because we will need to package all the signals from the same trading bot into a single file. I'm wondering if that makes sense to be sending signals from the same trading system over multiple trading bots, social trading bots. Does it have a use case? I'm not sure. Why would somebody wants to be sending signals through one bot, social trading bot, and some signal through another social trading bot? But let's say you want to do that. How is the other bot going to get synchronized? They will need also a candle end event. Well, yeah, you can send the candle end event also there. Okay, so I guess we will leave that possibility to end users to decide what they want to do. So as long as they provide the candle end event, that should work too. But essentially, what I mean is that okay, let's correct this. This is going to be the signal message. Signal message. I guess these signatures is not at the right place. It should be here. Signal message signatures user app is going to sign the signal message, the signal itself. Well, it's not going to sign the signal, it's going to sign the file key now. So the file key is going to be signed, not the signals. Okay, using the user app code name, which comes from here, which comes from here. Do the social trading bots got a code name? Yes. Well, it seems they will have to be unique because they are part of a map of code names. Okay. So things are starting to take shape. We have the user app that allow us to put this information here. We don't have the social trading bot here. Because we haven't sent that information. The social trading bot depends the social trading bot depends on each signal. Okay, so for each signal, for each individual signal, we can get which is the social trading bot, because we track it from the signal definition and we crawl the node structure until we find the social trading bot. So for each individual signal, we know which is the social trading bot, and we know which is the social trading bot code name. So my guess is that if we are going to send the social trading bot with all this detailed information, which is basically the idea of the social trading bot, we will need to get the social trading bot up to here. But what about this signal definition? Why is this here? Signal source. This probably should be here. We have the signal source and the signal definition. Okay. So as part of the signal message, we have the signal with all this information and the signal definition that is kind of informative. Well, it's not really informative, because based on the signal definition, then we are going to be able to retrieve individual signals. Okay, so if I move this signal definition from here, that means that in incoming candle, I will have it from somewhere else. Somewhere else. Yeah. So signal is now signal definition. Outgoing candle. No, here. So we remove it from inside here. So incoming candle signal. Okay. Okay, we are reshaping this. What about the broadcaster? Are we using this in here? No. Okay, now it's taking shape better. Let's check this out again. We got the signal definition, and the broadcaster is probably not the place here, because everything is going to be packaged into a one file per trading bot. So this is not the information for having here. So this gets simplified in this way. Okay. So each trading signal will have the source producing the signal. This is at the trading system. Someday could be at some other place. The node that is producing the signal, which is the type, formula value, context count. Okay. The signal definition used ID and type. Okay, now this looks better. So what about social trading bot and sign in account. We will need this with the signal. We got the social trading bot. Okay, maybe we can send this social trading bot because we need the social trading bot here for its ID mostly. Okay, this is gone. Um, social trading bot. Okay, we need the ID. We need the social trading bot ID at this point, and we don't have it. And here, what do we need? From the social trading bot, okay, we will need also the sign-in account and blah, blah, blah. So essentially, what you're going to do is get the social trading bot, signal definition, okay, so once we have the social trading bot, we don't need it here. So we can move these validations. We can move it inside here. And as long as we receive this guy here, somehow, this will continue working in exactly the same way. We will be able to put this in the signal message, and we are going to be able to sign the message with the private key of the social trading bot. Okay. Okay. So the next problem would be to send this. When we broadcast this trading signal message, we need to say this belongs to this social trading bot. So that means that when this gets here, we will push all this stuff And when we have it all together, we are going to persist it. We are going to persist it. But the problem is that I cannot persist things mixed of different social trading bots. I need to divide them into the signal of one bot on one side and the signals of the another trading bot on another side. And once I get the package complete from one bot, I have to make this persist. So I will need to make an upgrade here. So how do I do it by social trading bot? I will need this array to be inside of a map, a social trading bot map. Okay, so what I'm going to do is use the ID as the key of the map. And this LED candle signals is not going to live here anymore. So it's going to be what is going to live there is just the map. Okay, just an empty map at the beginning. So LED candle signals is going to be social trading bots map. We're going to get the element, an element by the social trading bot ID. So if this happens to be undefined, my God, if this happens to be undefined, then we are going to initialize one empty array inside there. So then this continues. Probably this is not going to be here. So then it continues. We're going to accumulate all the signals that are not the signal candle, the candle signal, which means that we present blah, blah, blah. So so we add, and when we send this guy to persist it, you're going to send it and you're going to say, look, this is the candle signals, all the signals of a candle of this guy, of this social trading bot. So at our um, at our guy, we are going to do a delete. So we are going to remove the array from our map because we already sent the array to be persisted, and the array is then recorded at the open storage module. Okay, so now we will go to the open storage where this is recorded, this persists. This will receive also the social trading node. Probably we should send, what if we send this in an object which include both the array and we'll create here let record equals an object with candle signals. I'm very specific here so it's as clear as possible, even if I had to type a little bit more. And then we send a record. That is exactly what this other guy is expecting. A record. And once we have that, then here this guy gets the record. No, that is not going to work because this is going to be, okay, why not? This is a record to be saved. So for each record that is saved, wait a minute, let's follow this. So it saved the record. Now I have in the record, I have both the array and the node, the social trading node. Records to save. So it's an array of records. Okay, the content will be record to save dot candle signals. We don't need to save the other stuff. So this is the content, record to save candle signal. Wait a minute. This is getting more complicated because this can accumulate this can accumulate candles and save them all together. So that means that this guy also have to distinguish which is the bot. Because one file is not just one candle, it might be many candles worth of information. So I don't think this is a good idea. And I don't think this sending this inside is probably a good idea either. We will need a similar mechanism. In this mechanism, we are accumulating signals per pot until we get all the candles and all the signals of a candle. So here, yeah, we are not going to send a record. We're going to send this. And this other guy will receive here candle signals and social trading bot. So the trick is more or less the same. Instead of having an array here, we will need a map. And probably the same map. Social trading bots map will replace this, and it will replace this. But let's bring it from here. We'll replace this and this. So when we say candle signals represent all the signals inside one candle. And this map is going to have an array of candle signals. So probably we can call these records. Records. We're going to get this array, and if this array is undefined, we're going to initialize it here. Okay, records to save. What's a good name, in fact? So then we will make a push of record to save. One more of these candles. Okay. So this is going to be accumulating this over and over and over, candle. So every 1 second, something is going to execute this, save one file, and the save one file, it will have to iterate over each of the it will have to iterate now over the map. This is getting complicated. It will have to iterate over the map because it will have to save a file for each trading bot. Okay, for each trading bot, for each social trading bot. So what this will do, we will create another function that is going to be called save multiple files. Save multiple files, and this is the one that we are going to be executing every 1 second. And we are going to take this map and we're going to create this for each value callback function value key array. Okay, so for each element on the map, we'll do a save one file with this value key. So what about the map? When do we add stuff to the map? That was not really covered here. So if we don't have this, social trading bot map, if this is undefined, that means that we have to initialize this guy, but also we need to add to set at this map with this key, this array. Okay, if it is not undefined, then we have the array, we add one more item. If it is undefined, then we initialize the array and we set this there. Okay, the same is true for this situation, because this is going to be also undefined at the beginning, so we need to initialize this with set with this key and the value of the array. Okay, so load file means load file, no. Save multiple files is going to iterate for each element of the map value key. So there is a problem there because I still need the node reference afterwards. So the node must be part of the value. I just cannot live with the key only. Okay? But if that were not the problem, okay, how do I fix this? I want to save one file. Okay, so records to save. Record to save, in fact, is going to be the value. So we can call it like this. Record to save and the key, whatever, we don't need a key. So if record to save equals 0, meaning there are 0 candles, we return. Okay? Okay. So the rest would work, but at some point we got the content here and record to save is gone. But the thing is that when we say broadcast file key, I need to send here this guy, the social trading bot, and I don't have it. Okay, I don't have it. So in order to have it, I will have to put the social trading bot. When I receive it here, record to save. Okay, we are not going to push candle signal. Here is what we are going to do. Let record equals candle signals and social trading bot. So we are going to store record there. So the content is going to be wait a minute. The records can be is an array of records. So there's missing something here because I need to iterate. I need to iterate over records to save to create a bigger content. Okay, let's review this again. We receive candle signals, whatever it is, and a social trading bot node. So we try to get from this map with this ID records to save. If there is nothing, we create an array and we set it in the map with this ID. Okay. Also, at the array we add one record. So if again we can receive the same trading bot with another candle signals, then this is not going to be undefined. That means that we are going to add a second item to this array. Okay. So if the length of this array is 0, we return. Otherwise, Otherwise, we will iterate the array of record to save. Okay, we are going to iterate the to say to consolidate all the content into a single array of signals. Okay, so each record is going to have multiple um, or maybe we don't have to, because this is already a record, this is already an array. The problem is that now at each record we are adding a reference to a node, so we are contaminating that array. We have to remove that. So what we need is, yes, we are going to need to iterate. So for let e 0 e less than then let content equals an array, and we're going to content push record candle signals. Dot candle signals. I don't really like it, because that means that the node is going to be repeated inside that record, and we just extracting that. But maybe what we need is a different approach. What I would do is to create social trading bots map and another map social trading bot candle signals map. Yeah, this is better. You will see. This is better. We're going to have this new map, and we are going to delete it here. So when we persist, we will have two arrays. Record to save is going to be the map for for candle signal. Wait, we will call this candle signals map directly. It's too long. The candle signals map. So this is the candle signals map. Candle signals map. So here we will get record to save from the candle signals map. If it is undefined, we will set with this key record to save. So record to save we will push this array of or this information of candle signal. No need to store this here. Now I have cleared my mind. So for each candle signal map and existent, but also here we will create, because we received this guy, social trading bot, we will have a map every time we add this here. We are going to add this map, we are going to set with this ID. We are going to store the reference to this node. Okay, so in the map, if we only have one social trading bot, we are going to store only one stuff of this with this ID, and that's perfect. So when we have to save multiple files, what we are going to do is for each bot what we have in this map. Now for each candle single map, that's okay, that is also by bot ID. We're going to save a file where we receive a value which is exactly the record to save all we have in record to save. So then the content is going to be directly record to save. That is an array of candle stuff. So we don't really need to iterate this because we already have this. We are going to record it at different. It's going to be an array of signals. So this iteration is not needed then, and we are just going to use as content this guy. But when we need to send, okay, this is the key, okay? The key in our case is going to be this, we can call it like this, okay? So with this key, we're going to get this map, and when we have to send the node in here, what we're going to do is say like this: the social trading bot, the node, is going to be equals to this get, and from here the social trading node ID. And this is what goes here. That is a reference to the actual node, and this is what ends up outgoing trading signal candles as a social trading bot. Um, broadcast file key here. It ends up here, and because we have the node, the complete node, then that means that we can access its config, have a code name, the signing account, and eventually calculating the signature and everything that we need. And then we route this to the send message of the peer-to-peer network. Okay. So this was a long session, but we completed half of the way of this second iteration of trading signals with all the mechanism needed. Obviously, we haven't tested. At the next episode, I will be doing the incoming, because the outgoing is clear now. The incoming should be straightforward. And after that, we will do a session debugging and testing that everything is working. So this was good. It was a good one. I'm happy on how this is taking shape. I hope you like it. And thank you for watching this one. And see you next time.